Hello everyone, this is Fateh Lohar, Assistant Professor, Department of Electronics and Communication at Engineering College, Alawar. The lectures is prepared for R2 syllabus antenna and propagation for 6th semester EC student. In these lectures, we will discuss the topics aperture and reflector antenna, Huygens principle. Second thing, we will discuss the radiation from the rectangular and circular aperture. Okay. These two topics we will cover in these lectures. Remaining topics: design consideration, Babylon's principle, radiation from sector environment horn, design concept, prime focus, parabolic reflector, and cassette gram antenna. We will discuss in next lecture. Okay. So aperture antenna. Basically, this type of the antenna is completely designed by the metal, and this type of the structure have high power handling capability. Okay, you can see this is the conical horn है, pyramidal horn है, rectangular waveguides. Okay, basically this provide the antenna is conduct electric field and magnetic field instead of the current and voltage. Okay, so this type of antenna generally used for high power handling capability for long distance communications, especially for satellite communications. Okay, a base station and satellite also have the same type of the element, and for radar applications. Okay, radar antenna also designed by the horn antenna type of this. Basically, they need high gain and high gain and large high gain and high activities. Okay, so aperture antenna are most common at microwave frequency. There are many different geometrical configuration of an aperture antenna. Is some of the most popular shown in the figure. Okay, they may take the form of the waveguide or a horn whose aperture may be square, rectangular, circular, elliptic, or any other configuration. Okay, aperture antenna generally designed by the waveguides. Okay, it may be a square, a rectangular, or else maybe elliptical. Aperture antenna are very practical for space application. Okay, because they can be flush mounted on the surface of the spacecraft or aircraft. Their opening can be covered with the dielectric material to protect them from environment conditions. This type of mounting does not disturb the aerodynamics profile of the aircraft, which in high speed application is critical. So basically completely designed by the metallic. So generally in case of the aerodynamic profile, okay, this not disturb antenna patterns and characteristic according to the aerodynamics profile. Now we first discuss the field equivalent principle, Huygens principle. Okay, in this principle, the field equivalent is a primary principle by which actual source, such as the antenna and transmitter, are replaced by equivalent source. Okay, meaning of this basically the actual source. Basically, actual source is transmitter, antenna. Okay, in this principle, we can represent in equivalent sources, single source. Okay, the fictitious source are said to be equivalent within a region because they produce the same field within the region. Huygens principle, which states that each point on the primary wave front can be considered to be a new source of secondary spherical wave, and that a secondary wave front can be constructed as an envelope of this secondary spherical wave. Meaning of this, the primary source can the secondary source and primary source. Basically, they are the two source. Okay. Meaning of they can be this. The equivalent principle is based on the uniqueness theorem, which states that a field in a lossy region is uniquely specified by the source within the region plus the tangential component of the electric field over the boundary, or a tangential component of the magnetic field over the boundary, or the former over part of the boundary and the latter on the rest of the boundary. Now we discuss. These are the two problems to design two plots. This is the actual problem. This is the equivalent problem. Okay. In this, Z1 and M1 is current density of primary source. Okay, and this is the V2. V1 is primary source and V2 is secondary sources. The equivalent principle is developed by the considering an actual radiation source. Okay, so which electrically represented by the current density J1 and M1. This is the primary source current density as shown in the figure number A. The source radiate field E1 H field everywhere. Source radiate E1 and H1 field. How it is desired to develop a method that will yield the field outside a closed surface. To accomplish this, a closed surface S is chosen. So in the basis lines, which enclose the current density Z1 and M1, the volume within S is denoted by V1 and outside S by V2. The primary task will be to replace the original problem. So in the figure number A, by equivalent one which yield the same field E1 H1 outside S within the V2. The same field is radiated to the V2 E1 and H1. The formulation of the problem can be yielded immediately if the closed surface is judiciously chosen so that the field over most, if not the entire surface, are known for priori. So an equilibrium problem of the 12.A 1A is shown in figure and 12.B. The original source Z1 and M1 are removed, and we assume that there exists field E1, E and H inside S, and field E1 and H1s outside of S. This field to exist within and outside S, they must satisfy the boundary condition on the tangential electric and magnetic field component. Thus, on the imaginary surface S, there must exist the equivalent sources Z1 and M1. This is the equivalent source of the in this equivalent model. Okay, this is equivalent source ZS and MS. Okay, basically this source generated E1 and H1, and outside V2 also generated the same E1 and H1, but this inside E and H and outside generated the E and H, because this is the same source is generated outside. Okay, and they radiate into unbounded space. Same to the current density are said to be equivalent only within V2 because they produce the original field E1 H1 only outside S. Field E H different from the original E1 H1 result within V1. Since the current 12.1 and 12.2 radiate in unbounded space, the field can be determined using the and geometry of the figure. In the figure, R is the distance from any point on the surface S where Z, S and MS exist to be observation point. Okay, this is the concept of the basically Huygens principle. Now we discuss rectangular aperture. Okay, rectangular aperture. Aperture means type of the slots inside the ground, infinite ground. Okay. In practice, the rectangular aperture is probably the most common microwave antenna. Because of its configuration, the rectangular coordinate system is the most convenient system to establish the field at the aperture and to perform the integration. So in the figure, this is the three type of the aperture according the direction of x, y, and z. Okay, they are the three most common and convenient coordinate position and used for the solution of the aperture. In figure 12.6a, aperture lies on the y and z plane. 12.6b lie in xz plane and 12.6c lie on the xy plane. For a given field distribution, the analytical form for the field for each of the arrangement are not same. However, the computed values will be the same since the physical problem is identical to all classes. For physically problem for each of the geometries shown in the 12.6, the only different in the analysis in the formulation. The component of the equivalent current density Jx, Jy, Jz, Mx, My, Mz. The difference in path from the source to the observation point R dash cosine. The different area D dash. So there are the three types of apertures: aperture 1, aperture 2, or 3. This is the plane of the aperture is YZ. X direction of direction, and this is X or Z is aperture plane. This aperture plane is X and Z. This aperture plane is X and Y. So we discuss completely in table format. Okay. First we discuss uniform distribution aperture on ground plane. Okay. So in this is the uniform distribution of electric field. Okay, in y direction. Electric field in y. This is the aperture, rectangular aperture. This is the rectangular aperture in the infinite ground. Basically, we design an aperture in infinite ground metal. Okay, so the aperture length is A and width is B. Okay, so in this electric field is constant throughout minus A by 2 to A by 2 and minus B by 2 to B by 2. Direction of the electric field is B, in B direction. Okay, yeah, in Y direction. In that case, according the concept of the Huygens principle, Ms and Zs is, in that case, Ms 2n and E A minus A by 2 to A by 2 in this case. Elsewhere 0 0 and Z is 0 everywhere is Z. Aperture current density is everywhere 0. Similarly, the radial component of electric and magnetic field is 0. Similarly, the electric component for theta directions is given is this C sin theta sin x by x sin y by x and y, where x is Ka by 2 far field zone field. Basically, this is the part Ka by 2 sin theta cos phi, y Kb 2 by 2 sin theta and sin phi. Similarly for J, C is equal to J Abk E naught E minus K J Kr by 2 pi r. So this is the field for the uniform distribution aperture. Similarly for the uniform distribution aperture in free space. In case of free space, this is the only the aperture, not including the ground plane. So this type of component only. This is the TE10 mode distribution aperture on ground plane. Okay, so in this case the electric field is not constant throughout the. Basically the electric field is minimum at the edge of this and at this, but maximum at middle of this. Okay, so the field pattern is A y E naught cos pi by A x dash and the remaining component is according to depend on the structures. So these are the half power beam width for 3 of the case, full null beam width in degree. These are the for 3 case, and field side lobe maximum to 3 of case. Okay. directivity of the case 1, case 2 and case 3. Okay. Okay, so in next lecture we will discuss about the circular apertures.